Hello, I'm Mr. Dance. Our topic today is probability. Ms. Klee and I gathered this information for everyone listening. Today we'll be discussing three topics: conditional probability, independent probability, and dependent probability. Looking at our first term, a conditional problem will have data given to compare. If a given event occurs, what is the likelihood of another event happening as well? Independent probability is a theory that two events are independent and have no correlation. Last but not least, dependent probability, which is two events that are dependent if the outcome or occurrence of the first event affects the outcome or occurrence of the second event. It is a dependent outcome. Our first problem is going to be conditional. Find the probability that a person from ACO shot expert on their qualification. Here we're looking at ACO and expert. ACO and expert. A and B. A is an ACO. This is going to be our first data set. And our second is after we add all three to get 37. So with these two, we're going to take 12 divided by 37, which is going to give us a decimal. And then we're going to simplify that. In this case, we're not rounding up. We're staying the same to our fourth digit. And then we're going to convert that into a percent so that we can see what the percentage is that we will choose a person from ACO. That is an expert. And that is 32%, 32.43%. That is an example of a conditional problem. An independent problem is solved by multiplying the probability of A and multiplying the probability of B. Here's our question. Given two 6-sided dice, complete the following. What is the probability that you will roll a 1 and 3? We are going to first have to solve what is the likelihood that we will get a 1. With that, it is going to be the probability for a 1 is 1 out of 6, since there's 6 sides. When you divide that, you get 16.7 or 0.167, which is going to equal 16.7. Then finding the probability for 3 is the same, because 3 is also 1/6. So to get your outcome, you have to multiply your probability of A, which is 1/6, times the probability B to get also 1/6. So 16.7 times 2, which is going to equal 33.4% chance of getting that outcome. The way we know that this is an independent problem is because A and B are equal to 33% or 33.4%, and the answer is 33.4%. What I mean by that is the 1/6 probability for A and the 1/6 for B are added together are the same as the outcome. Our dependent problem is also going to be a dice problem. It is what is the probability that you will roll an even number and 6. So first, we are going to look for our even number. With our dice, we are going to see that we have 6 opportunities, and 3 of those opportunities are going to be even, 2, 4, and 6. So that is going to be 0.5 and 50%. To find 6 is also going to be 1/6, which is equal to 0.167, which is equal to 16.7%. Next, we're going to multiply decimals to keep track of the decimal when in the last step. So 0.5 times 0.167 is equal to 0.0835, which is equal to 8.35% chance of rolling an even number and then rolling the number 6. Now that A and B does not equal the outcome, so it is dependent. What I mean by that is adding your 1/2 and 1/6 does not equal 8%. So 50% plus 16.7 does not equal 8. So that will make it a dependent probability or a dependent problem. Thank you for listening, and I hope this helped you. Have a good day.